We're looking at number 8. Number 8 says prove whether the quadrilateral is a parallelogram using the distance formula. Q, R, S, T, Q being at -10, -2, R being at 1, -1, S being at 1, -7, and then T at -11, -8. So what we have to do is use the distance formula. So what we have is distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our distance formula we're going to use. So what we're going to do to kind of visualize what we're doing is let's just take a little graph about it. Let's just see what the graph will look like and see what information we need. Then we're going to use the distance formula. So what we have here is -10, -2. We're just going to do a rough sketch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. Like I said, we're just doing a rough sketch to see what we're working with. So this is Q. Now we're looking at R, which is at 1, -1. This is R. So they're connected. I'll use a ruler just to make sure I'm precise. Then this is at 1, -7. So 1, 2, 3, 4, 5, 6, 7. So this is right here. And then we have T, which is at -11, which is going to be 1 over down 8. So down 8. So be one more down here. So about right here, which is T. So we're trying to prove it mathematically. So we can just get a visual of what we're comparing. Because we don't know if it's going to be it or not. Because right here, this is a rough sketch. I'm not using a graphing calculator. I'm not using Desmos, which is a graphing calculator, or I'm not using line paper. So right here, this just gives me my information. So I can compare QR to TS, or I can compare QR to ST. It doesn't matter. I'm just going to choose just the basics. For this, you could always choose the first two and the last two together. So we're going to compare the following information. We're going to compare these, because if it is a parallelogram, that means QR has to be the same distance as TS. If that's true, it's going to be a parallelogram. If it's not a parallelogram. So we're comparing QR to TS. So we're going to label this X1, Y1, X2, Y2, so on and so forth, just to make sure we know what we're doing. So we have right here Q is at -10, -2, and then R, which is at 1, -1. X1, Y1, X2, Y2. We use subscripts to keep ourselves organized. We're going to be finding QR first. So QR, so the distance of QR is equal to the square root of, we're doing X2 first. So X2 would be 1 minus -10 squared plus -1 minus -2 squared. So what we have here is -1 minus -10 becomes 1 plus 10, which gets us 11. So we have the distance of QR is equal to the square root of 11 squared plus -1 plus 2 would give us a 1 squared, which would end up with the distance of QR is 121 plus 1, which would ultimately would give us the square root of 122. Now we want to find the distance of TS. TS has to be the same length as QR. So T was at 1, -7, and T is at -11, -8. So right here we have this as X1, Y1, X2, Y2. So the length of TS is equal to the square root of x2, negative 11, minus 1 squared plus negative 8 minus negative 7 squared. So right here, negative 11 minus 1 would get us, 12 squared, so the square root of 12 squared. Negative 12 squared, and then we have negative 8 plus 7 would give us a negative 1 squared. Negative 1 squared. You get this is equal to the square root of 144 plus 1, so you get this is equal to the square root of 145. So if we were to compare them, look at it next to each other, QR is the square root of 122, and TS is the square root of 145. As you can see, messed up. As you can see right here, when we compare those are not the same. So since they're not the same, it's not a parallelogram.